So this is M64, it's Consequences of Global Climate Change. So basically this section, we delve into climate change and kind of the effects. We talk a little bit more about the indicators of climate change. So if we look at melting glaciers and melting ice sheets, so these are kind of seasonal. And so in some places, a lot of people rely on this as drinking water. So for example, near Glacier National Park, they get a lot of their drinking water from the seasonal melting glaciers. Well, the glaciers have dwindled, and projections are that Glacier National Park will not have any more glaciers in the coming years. And so other places, besides just Glacier National Park, but other places that rely on glacier melting, they would have a decrease in their freshwater. And we learned a while back how freshwater is scarce in some areas of the world, and there's just not enough to go around. So definitely a concern there. And then another thing that we might see is sea level rising. So as ice sheets melt and glaciers melt, that runoff goes eventually into rivers and then eventually into the ocean. And so if they melt, that could cause sea level to rise. And it basically rises for a couple reasons. So you've got sea level rising because fresh water, of course, or just water in general, is entering the ocean. But then also the reason that glaciers and ice sheets are melting is because of the warming of the earth. So that means that the oceans are taking in that heat. And as water heats up, it expands. And so not only are the oceans increasing in height slowly, but they're increasing in height because of the melting, but also because of the increase in volume, because of the thermal expansion. And so I put that on here. And then basically it's going to affect the coastal cities. So there's about 100 million people that live near coastal areas. And some people live in island areas where it's going to be completely covered if the sea levels rise even a meter. So definitely going to displace people. It affects wetlands. So we've got a lot of wetland biomes that are along the coast, and definitely would affect those too. And those are huge ecosystem services. And so we may lose those as well. So that's another kind of concern. And then looking at habitat loss, the fragmenting of habitats. So we looked at the island of biodiversity theory. And so if we have all these fragmented little in a sense, inland islands, little areas that are preserves, but they're not connected, so we don't have corridors for the organisms to migrate through, then basically if they need to migrate because of climate change, they can't. So that creates a huge problem, and so if they can't migrate, they can't adapt, they're not going to survive. So definitely a concern. So that's one other reason to make sure that we have interconnected sanctuaries for organisms so that they can migrate, especially large migrating organisms. And then this section, definitely need to read this section. So this section talks about several different things, but mainly polar bears and the pied flycatcher. And so basically these two animals, they are, the flycatcher is not, it talks about how the caterpillar hatches and the birds nesting is kind of correlated with that. So their hatchlings hatch around the time that the caterpillars are abundant so that the babies can eat. Well, that's not happening. The caterpillars are coming out earlier because the blooms are happening earlier, but the bird is not adapting. The eggs are still hatching at the same rate at the same time of the year. And so they are saying that their numbers have decreased by 90%. So that's definitely a threatened species there. And then the polar bears, another thing, they rely on sea ice. And so if sea ice is dwindling, then they don't really have a place to hunt for the seals. And so that means that they can't, gain enough weight for their hibernation in the winter. And so they are not going to, and it's not something that they can just adapt to. So if sea ice is gone, in the North Pole, in the Arctic, then polar bears are going to be gone too. And so those are two species that are declining, definitely indicators of climate change, and definitely something that are kind of, showing us how things are really connected and how we need to preserve and protect these environments. Another thing that we might see with global climate change is heat waves. So heat waves would, in a sense, be a positive feedback. So let's say that we have an increase in temperature, and then we have an increase in electricity use because now we need to cool down your house. So also, if you have a heat wave, then it tends to follow a drought or be at the same time as a drought. And so then that means that you're increasing the water use. Well, then now our fresh water is dwindling. In order to use water, in order to use electricity, we have to use more than likely some type of fossil fuel for electricity. And then now we have an increase in CO2 usage and therefore an increase in global warming. And so it just carries on and kind of escalates. So definitely a positive feedback. You can think of it as a positive feedback. And then cold spells. Cold spells can be nice. Reading, having a cold spell would be awesome. So it's definitely good for the humans. So that would be a plus. But bad for pests. So sometimes we have, if we have less cold spells, for example. So some areas, with global warming, it doesn't all warm everywhere. So some areas can get colder than usual, and some areas will get warmer. But let's say that we have a decrease in cold spells. So instead of an increase, a decrease. So instead of getting the Midwest this winter was extremely cold. So if we had a decrease in that, then that's a plus side for the humans. But it can be bad for pests as far as if temperatures are really cold, it tends to kill a lot of pests, like insects, for example. And so if it doesn't get cold enough, then those pests don't die. And so now we have an increase in pests, especially bad in the Midwest. So that can be a downfall for humans as well. So it can be both a good thing and a bad thing. Depends on how you look at it. And then storm intensity. If we look at hurricanes form in the Atlantic, and then they're carried over by the Gulf Stream towards the U.S. And they have to have about 82 degrees Fahrenheit water temperatures in order to form. Well, hurricanes are driven by warm water and crosswinds. And so if the temperatures rise in the ocean, then that can potentially increase the intensity of the storms. And in the last 10 years or so, we've definitely seen an increase in intensity of hurricanes. Whether it's driven, by global climate change or not, that's up in the air. But as far as what's intensifying them, could be the temperature in the ocean. So we could see an increase in hurricane intensity because of increase in temperature in the ocean. And then there's this thing in the ocean called the thermal haline conveyor belt. And what this is it's driven by densities of water, and it's driven by temperature densities, and it's also driven by salt density. So in the equatorial region, there's lots of evaporation, so the water tends to be pretty dense. So it sinks, but it's warm. And so as it migrates towards the polar regions, it decreases in salinity, but it decreases in temperature. And so that causes it to sink. So our coldest, densest water is at the poles, and the less dense water, even though it has lots of salinity, it's less dense because of the temperature at the equator. And so you get this thermal haline belt that's kind of driving temperature. It's taking the warm temperature from the equator and it's moving it towards the poles. So it's kind of regulating temperature. So what happens if you add a bunch of fresh water to the ocean is that you get a slowdown or even a potential stop in this thermal haline conveyor belt. And I'm not sure if the book will address it later, but this could be a potential cause. People have looked at this as maybe a potential cause of ice ages. And so if you don't move the heat from the equator to the polar regions, what you get is a over freezing of the polar regions. And so that's typically an ice age. So it could be a kind of a way of the Earth regulating itself. So if the Earth gets too warm, it could potentially drop into an ice age. So that's something else that people look at with global warming is, are we intensifying this and bringing on an ice age earlier than it should? But anyways, going back to the thermohaline conveyor belt. So it's disrupted. Either way, with fresh water added, it's disrupted, it changes. And so that changes the distribution of heat on Earth. And that's caused by too much fresh water. And then looking at humans' effect. So a lot of diseases are magnified by rising temperatures. And so a lot of viruses, organisms, bacteria thrive on warmer temperatures. So that could basically increase disease for humans. And then another thing that it can be, it depends on how you want to look at it. It could be a good thing or bad thing, but tourism can change. So let's say, looking at Mount Shasta, for example, I moved here when I was a junior in high school. And I've lived here for a while, except for going away for college. And so I have never, since the last 5 years, have I ever seen the park closed for not having enough snow. And lately it seems to be kind of the norm. This year, an El Nino year was a little bit different. But that is something that's becoming more common. Well, different places. So, for example, Mount Shasta, the last couple years, they've had mountain biking in the summer, which is awesome. But some of the resorts, so let's say that Mount Shasta continues to get not enough snow, or their snow melt happens a lot sooner. So what some ski parks are doing is they're opening up to mountain biking earlier. And so that could be a potential change. So however you want to look at it, embracing it, let's say that Mount Shasta continued to get less and less snow, so that maybe the ski season, if there is one, is only maybe a month long. Well, that extends, potentially a mountain bike season. And what I've seen and what I've read, and here's a picture, which reminded me of it, but Vail and I can't think of the other one, but there's a couple in Colorado. So they have opened up everything to mountain biking in the summer, and they've really kind of extended that and made it a big deal. And they actually make more money off mountain bikers in the summer than they do skiing in the winter. So mountain bikers, I guess, tend to supposedly spend more money and stay longer. And so I guess their revenue is up in the summer. And so you can look at it both ways. So Mount Shasta, let's say that the snow went away, they can embrace that and have more of that. And so tourism changes. So definitely people can adapt and change what they do. It doesn't pertain to places maybe if the island disappears because the ocean rises. But as far as what I'm talking about, tourism does change, but people can adapt to that. So it's not a huge concern. And then this last little section, this is a big section, not a big section, but a lot of information on this page. So it's page 712. So I put that on this sticky note. There's a lot of information. Make sure you read through this really closely. There's way more than I can explain or write on sticky notes. But what you need to understand on this page is the Kyoto Protocol. So what exactly is that? Why it was developed, and who's a part of it? And then carbon sequestration. So this is something that we're going to actually measure with trees in class. And so we're looking at how much carbon does something take in. So a tree, it could be in the form of carbon credits, carbon trading. And I mentioned that a few chapters back, but that could be, a way of combating CO2 emissions. And then what is the reasons behind the U.S. not ratifying the Kyoto Protocol? So there are reasons, and I think they're legit reasons. But so basically Kyoto Protocol is saying that countries can or need to limit the amount of CO2 that they produce. But what it didn't do was put a limit on developing countries. And so developing countries can pretty much emit what they want. So the problem that the U.S. had with it when it was first developed was, well, that's not right, because China is now the biggest emitter of CO2, not per capita, but per the country. They weren't at the time of this Kyoto Protocol. They weren't even a player in that. So it doesn't put any limits on them. And so that's a huge problem, and the U.S. didn't really like that. They wanted some changes to be made and some limits to be put. But developing countries often don't have a lot of money. And so they didn't want to put limits on those developing countries because they wanted them to develop. So there was some issues with that. And so that's one of the reasons that the U.S. Didn't ratify it. But there has been some changes to it lately, but the U.S. is still not a part of it. And then what's really recent is the Paris Climate Accord. And so that's been in the news lately. And so that's the last little section in here. So just read about that and understand that the U.S. has chosen not to be a part of that as well. And the book doesn't really go over, I mean, this is very new. So the book doesn't really go over exactly why. And you won't be tested on it. Not new information. They never test, I guess, is what I've heard, on really, really new information. Because not everybody has a brand new book like we do. So anyways, but know these things, especially the Kyoto Protocol, and how that relates to CO2 emissions. And that is it for M64.